Hey everybody, this is going to be the fifth video in Module 3. We're going to do a little bit of programming. I'm hoping to try to follow along with the regression in R PDF. So here's that PDF for you guys to check out. I'm not going to follow along 100%, but I'm going to try to do the best I can. Maybe I'll show you guys a little bit more, but we'll see as we go. So anyway, let's get started. So the first thing I'm going to do is I'm just going to go from scratch. So when I know I'm going to do some sort of analysis, I always start with loading packages I know I might need. So for example, the first package I know I'm going to need is Stargazer. So that's going to be how we're going to view some of our output. You can run this line and you're going to see this please cite message come out here. That means it worked. If you haven't installed this yet, if you've never used Stargazer before, you have to do install.packages, Stargazer. Run this line. So either hit Control Enter or Command Enter if you're on a Mac, and it'll run. It will install the package for you, and then you have to load it in with the library. Then you should see this, and you should be ready to go. The second thing we're going to do is I always like to start with this line of code, where what this is going to do is suppose I had something in my environment here, it'll just clean that out for us. So for example, suppose I had, I'm going to open this up, make it a little bigger. So suppose I had something that looked like, so if I had these two, if I had these two things in my environment from last time I was using R, I might want to start with just a new blank workspace to make my life a little easier. So I'm just going to use that line. It'll get rid of everything for me. The next thing I'm going to do is I'm going to set my working directory. So in the data files section on eCampus, there should be a, let me look what it's actually called. I want to get it right. Texas Crime and Unemployment. You can download that and store it on a folder somewhere or your downloads. And that's where we're going to set our working directory to. So for example, I'm going to have set WD, and I have this econ 425 folder on my desktop. If I open it up, this art history, this is from when I was playing with the data before. We can delete this. It shouldn't even be there. But Texas Crime and Unemployed.csv. So what I'm going to do is I'm going to hit Control C. If you're on a Mac, Command C. But I'm going to copy it. I'm going to put it there. So it's going to have the entire file path. But what I'm going to do is I'm going to get rid of this. So just backspace. And then I'm going to go over here and I'm going to cut this. So Command X or Control X on a PC. So I'm just going to cut that, get rid of this. Now here's going to be my working directory now. So if I run this, let me show you the output, it accepted it. And we can see here it says my new working directory is right here. So I'm going to read in my data. I call it Texas, read.csv. Paste that there from when I cut that before. And I'm going to say strings as factors is false. So if there's any kind of text in there, it will read in as text or string instead of a factor variable. So I can write that. Okay. So the first thing I do when I read in data, I always try to do view head Texas. So now here we can check out, here's what my data might look like. So I have a county name, a year, a county code, population, looks like total, population male, female, right? These are missing values. When you see an NA like this, a little bit grayed out, you know it's missing. You have labor force, employed, blah, 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 all this information, right? So that's what my data looks like. So if we go back to the regression in R PDF, the first thing under the example is we read in the data, and the second thing is we create this variable called prop crime rate. So I'm going to copy and paste it from the PDF. Sorry, I had a timer. So what I have now is I'm going to replace this equal sign with an arrow. In a lot of the PDFs, there's an equal sign instead of arrows here. I'm going to always just if I have it, I use this. I think it's slightly better, but I think I discussed that in a previous video. But anyway, so what we're going to do is we're going to take the property crime, so the total number of property crimes in a county in a given year, and we're going to divide that by the total population in a county in that year, and then we're going to multiply by 100,000. So that's going to give us a crime rate per 100,000 for property crimes. So here's all the data, and we can see we have these little missing, these little NAs, which mean missing data. So that means that one of these two things is missing, and it can't actually come up with a number. So anyway, we just have to keep that in mind that there is missing data here. So if I run this, I have now created this new vector, this new column in my data. So maybe the first thing I want to do is I want to take a look at it. So first, maybe I want to look at, okay, what's the mean of this Texas prop crime rate? It gives me an NA. This is because we have those missing values in it. So what we're going to do instead is we're going to do na.rm equals true. So this is going to give us an average. So the average per capita crime rate per 100,000 is going to be about 2,000 crimes. We can also do, maybe we're interested in the standard deviation. So that's about 1,500. Or we can just use this thing called summary and get a little bit of like of an everything with this. So it gives us the minimum, gave us a maximum, gave us the number of missing values, 254, gave us a median value, anything you might want to look at, right? But now maybe we want to visualize this. So maybe I can start with a histogram. Texas prop crime rapid and hist. And if I plot this, it gave me this error. Plot.new figure margins too large. If you ever get this message, it means that this window is simply too small. You just have to drag it a little bit this way, drag it a little bit this way. If I rerun that same exact code, it'll make the data perfectly, or make the plot perfectly. I can also control how many breaks I want. So I can do breaks equals 100. It'll be a little bit more. Okay, so this is a good example. Suppose I don't know what the actual argument is. I can do $hist. I thought it was breaks, but it might not be. If I look into here, we have breaks equals Sturgis. Not sure what that means, but I think it is breaks. I'm not sure why it didn't work. Oh, I think I had double equal sign. So that was a good example of when to use the help thing. But if I break it down into 100 different bins, you can see now, okay, it's a little bit more of a normal distribution, it looks like, but it has a really long tail over here. And this more looks like it's just always decreasing, but in actuality, there's actually pretty big median right around here. But anyway, so the next thing we want to do is, maybe we want to look at this regression. So we're interested in the effect the unemployment rate has on property crime rate. So let's just write that down. So interested in effect of the unemployment rate on property crime rate. In other words, we are interested in explaining the crime rate equals beta 0 plus beta 1 times unemployed rate plus epsilon. So this is the formula we're going to try to estimate. So we're going to try to estimate this beta 0 and this beta 1. So essentially, before I do this, I just want to plot the data and check it out. So I'm going to load in this package called scales. We don't need this. I think we did it before. It controls the opacity just so we could see a little bit better what the data looks like. But you don't have to use this. You just have to, instead of, well, I'll do two. So here's library scales. So if I wanted to plot Texas unemployed rate, Texas prop crime rate, color equals blue, PCH equals 19. This 19 is going to mean filled in circle. Blue is just going to make it a blue. And we're just going to plot it. So if we do this, it takes a second. So we get this massive blue, couple outliers here, couple outliers here, right? So very, very high rates of unemployment, very, very high rates of property crime. But instead, if I wanted to use this scale package, what I can do is copy and paste that. I could do alpha blue, and then maybe I'm going to say the opacity is going to be 0.1. I still think this is going to be too dark of an opacity, but let's give it a try. Oh, this guy. So now we can see a little bit more. Okay, it's concentrated right here. We can see there's some sort of trend. Maybe it looks like this. Not totally sure. Maybe we can do one more. Oops. Enter. Maybe instead of 0.1, we can do 0.02, which is a 2% opacity. Let me plot this way. Give it a second to register. So now we can see, okay, this is where the effect really seems to lie. This is getting really, really light. I'm not even sure if you guys can see that, but they're kind of disappearing. But we can see there's some sort of mass right here. So this is where it's probably going to try to estimate that line. So let's run a regression, right? Let's call it reg1. Let's save the regression that we're going to run. So we're going to do linear model. And the first thing we're going to put in this is our variable for crime rate. So our dependent variable, our y variable. So prop crime rate filled in for me. That was nice. I do tilde, and then I do unemploy rate. And then I just have to tell it where these variables come from. So data equals Texas. I can run that. Now it's produced a regression for me, reg1. If I open up reg1, I have coefficients, residuals, effects, fitted values, rank, assign, QR. Some of these things might sound familiar, like coefficients, residuals, fitted values, right? These are all things that we were talking about before. So the first thing to do is let's just print reg1. Let's see what the output of reg1 looks like. Well, it gave us a call, so this linear model, this is exactly what we typed. We didn't have formula equals, but R assumes that if the first element looks like this, it's going to be a formula. The second thing is coefficient. So we have an intercept and a beta 1. So our intercept is going to be 1800. Our beta 1 is going to be 80. So if I want to draw a line, I want to draw our line of best fit on this plot, I would just do AB line reg 1. And I want to do color equals, let's do dark green. I'm going to make it a little bit thick. So LWD equals 2.5. Wait for a second to register. And you can see here's kind of what we kind of expected. I think I would have thought about it going a little bit more this way, but there are a lot of observations out here that it has to fit. So this is our line of best fit. This is our line that minimizes the sum of square residuals. So all of those algorithms I was showing you, the method of moments, the calculus version, there's just a matrix algebra version that's going to do that for us, and R knows how to do that behind the scenes just with this LM, so with this LM function. So great. Now we know an intercept and we know the coefficients, but now maybe we want a little bit more information. Maybe we want to know the standard error, we want to know the R squared, things like this. So the first thing we can do is we can do summary again. So we did summary before, when we were looking at just one variable, but now we're going to do summary of reg1. This is the base R way of how you look at your regressions and you can analyze it. So if I run this, I get this whole output, and make this a little bit bigger. So you get this output, it gives you to the call. So what the data what the formula looks like. Some information about the residuals, the minimum residual, the maximum residual, the median residual. It gives you the coefficients with a little bit more information now. So now it tells you the intercept, the estimate, which is what we had before. It gives you the standard error. So we were talking about standard error before. That's the that variance or the standard deviation estimate of our estimate. A t-value and p-value, this should be somewhat familiar if you were took Econ 225. You should kind of remember what a t statistic is or a p-value. We spent a lot of time on that in that class. It tells you your R squared. It tells you how many observations were deleted due to missingness. So for now, things that are important would be the R squared, the estimate, the standard error, and anything else that you care to talk about. But we will discuss all of these things throughout the class. But for right now, we've touched upon estimate and standard error and this R squared. So another way to view regression results would be with Stargazer, which I think is a little bit better. So for example, if I did Stargazer Reg 1, if I run this, it's going to output something that looks a little bit nicer than this, I think, but it's going to do it in LaTeX, which is a text editor that's used for writing PDFs and academic articles. So for example, here's a bunch of nonsense. You can see there's words in here, but what we want to do instead is we want just a text output. So we want to do type equals text. And now here's what we get. We get our dependent variable, property crime rate. We have unemployment rate. This is going to be our beta 1 with our standard error in parentheses and a little shortcut notation for our p-value. If you see this before, see this p-value's had stars here. We're going to have stars here. Same thing with our constant or our intercept with that standard error as well. And then you have observations, R squared, things like this. So this is great. We know how to run a regression now. We know how to analyze it and hopefully begin to interpret it. So for example, if we increase the unemployment rate, the property crime rate per capita per 100,000 is going to increase by 80. So that means that there's some sort of incentive for law enforcement to try to keep the unemployment rate low, right? This is kind of an important result. So if we keep going down on the PDF, the next thing that we talk about in the PDF is heteroskedasticity. So what we can do is, okay, let's just see if there's any kind of heteroskedasticity in the model. So we can do plot reg 1 residuals. We want that to be our Y value. So in other words, I want to plot our Texas unemployed rate, right? Because we want to see if there's a correlation between X and our epsilons. So if I run this, I get an error, and it's telling you X and Y lengths differ. So let's check it out. Let's do the length of this, and then let's do length of this guy. They are indeed different. So what it's trying to say is it can't match up to these because there's a different number of residuals than there are unemployment rates. And you might think, okay, well, why was that? And that was because we had missing data when we were running our regressions. So what R will do is if it has missing observations, it drops that observation and reruns the model on the full observation set. So what we have to do is there's a few different ways we could do this. The first way to do this is we could do plot Texas unemployed rate, and we could do reg 1 residuals. And we can modify this, we can shorten this up by saying not is.na Texas, and then find the missing one, which was property crime rate. So if I plot this, that will work for us. So another way to do this would be plot reg 1 model unemployed rate. So that's going to be the unemployment rate used within the model. And then I can do comma reg 1 residuals. And this will give me that same exact plot. It's not going to change very much. Maybe this will change. Yeah, so this bottom label changed so you know that the actual data is different, but the actual plot's the same. So here, maybe I want to do the same thing I did before where I had BCH equals 19, alpha, blue, 0.02. Now we can see if there's any sort of pattern here. So it looks relatively flat, but something we can do is we can then plot the AP lines. We can do a horizontal line at 0. So H equals 0. And we got that guy. So it looks like there might be some sort of pattern here. Like I think there's more variance probably here than there is here. But you can start to calculate this type of thing. So for a final note, suppose if we had a second regression. So we have reg 1 done, right? So now we can do reg 2, or maybe instead, and I'm just making this up, maybe instead of this, maybe we want to do a log-log model. So remember, this would be percent changes now. So a 1% change in the unemployment rate will cause a beta 1% change in the property crime rate. So we can do this, right? So it gave me errors because there's going to be NA values or missing values in Y. So what we're going to do, so we could do where you can't take the log of 0. So we're just going to make sure that the observations are greater than 0. So we can run this model now. We have reg 2 now. So we can do summary again of reg 2, where it gives you this. So now what we're saying here is a 1% increase in unemployment rate will lead to a 0.3% increase in the crime rate. But we can also do Stargazer, where in this way I can do reg 1 and reg 2. So I can compare the two, and I can do type equals text. I could run this, and now I get it in 2 columns, where it's a little bit easier to see in 2 columns than I had with it. And if I had to run this one and then a second one, this is a little bit easier to see, I think. So we can see the R² went up, but again, that's not necessarily, doesn't really necessarily mean anything. But we have different coefficients because we have to interpret our results differently, because now we have log and log. So hopefully this is a little bit of a good primer for how to run regressions in R. So if you have some data that you're interested in just throwing together, you can try these linear models and see what you get and kind of print out some results. So yeah, and then in the next chapter, or the next module, sorry, we can begin to use multiple variables. So instead, maybe I can I can explain the crime rate through unemployment and through the labor force, and through crime rate for property crime, and I can also look at the murder rate or something like this. Maybe there's more murders, maybe there's more property crime, things like this. But anyway, until next time in module 4.